All right. You done the unit circle yet? But you haven't gotten to it yet this year. You just started, so they've just basically gone back over SOHCAHTOA and okay. Do you have some problems you can bring? Because I mean, Trig's a long subject, and I could break some problems, but I don't really know where you're at. Although I can start at the unit circle. I guarantee you're going to get to the unit circle very soon. Okay. So let's start with the unit circle. I have kind of a standard session that I've given repeatedly to people who do the unit circle, and it's about a full session's worth. So here, let me draw some things on here. All right, we're gonna end up here. I think you're gonna be able to take a picture and capture all of the important stuff. And then I'm going to say memorize everything you see on this page. Okay? You got these two triangles. Make sure you know these two triangles, everything about them. Mainly, what are their dimensions? What's the 30-60 right triangle's dimensions? What's the dimension opposite the 30? I call these my unit special triangles. And the reason I call them the unit ones is because the side opposite the smallest angle is always 1. Okay? In other words, if the side opposite the 30 is 1, then this side is square root of 3, and this side is 2. Memorize those dimensions. Okay? Always know what the side of 30, opposite 30 is. Now, it could be 10, 10 root 3, and 20. So it's in multiples. So sometimes when you see this in a book, they'll stick an X next to the 1 and the 2 and the root 3. I don't really like to do that. I think that confuses the issue. Okay. On the 40-40, on the 45-45 right triangle, it's 1, 1, right? It's isosceles. In other words, if it's 45-45, that's an isosceles triangle, and both those sides have to be the same. So if you know one of them's 1, the other one's got to be 1. What's the hypotenuse on that one? Use the Pythagorean theorem to remember what it is. Here, I'm going to put this up here, but that's not part of what you're going to need to remember, although it's extremely important. But for the most part, once you memorize these dimensions, you don't need to use the Pythagorean theorem. So what is C? C equals the square root of a squared plus b squared. So what is C? Square root of 2, not 2. Okay? So that's definitely something, everything up there now you got to know. Okay? Now, it's called the unit circle because it has a radius of 1. Oops, got that backwards. In other words, this point right here is 1, 0. What's this point right there? What's the x-coordinate? 0, 1. What's this point over here? On the left? Yep. Yep. Just think what's the x-coordinate first, and then what's the y-coordinate. That's all you have to do. Don't memorize them as pairs. Think of them individually. What's the x-coordinate? Okay. Okay. Now, let's start creating. I'm going to use different colors for this. Angles. Call that 30 degrees. Notice that that has a length of 1. Okay. And if we create the rest of that triangle, what trig equation, and I'm going to call this y, and that x, right? In other words, the base of that triangle is x, the height of it is y. So, what can I say about the sine of 30 degrees? Starting from SOHCAHTOA. What is it equal to on my blue triangle? Start from the angle, find the opposite. What's the opposite? What's the rest of it? Over 1. Y over 1, which is the same as just y. Okay. Now, what's the cosine of 30 degrees? Yeah. X. So, in our unit circle, this point right there has coordinates cosine of 30 degrees, sine of 30 degrees. You see why? In other words, the x-coordinate equals the cosine of 30 degrees. The y-coordinate equals the sine of 30 degrees. You with me? Okay. Now, if we look at this 30-60 special triangle, what is the cosine of 30 degrees? Get used to doing these. That's what trig is all about, is just doing these over and over and over again. Looking at a triangle and figuring out what the sine, cosine, or tangent of a particular angle is. So just go through the methodology. Cosine is adjacent over hypotenuse. What's the adjacent? No, in this particular case, I've given you an angle. So instead of writing cosine of 30 degrees, let's replace that with a number. And you can always get that number from these two triangles. Just go up to the triangle on the left, the top triangle in red, and figure out what the cosine of 30 degrees is. Adjacent over hypotenuse. No, what's the adjacent? No, I want you to look at this triangle on the top left. There's no x in there. Okay. So it's square root of 3 over 2. That is the cosine of 30 degrees always, always has been, always will be. In other words, if I gave you a triangle that was this, that's still a 30, 60, 90. And notice that the ratios do not change. 10 root 3 over 20 is root 3 over 2. So that's why the only triangles you have to memorize are these unit triangles. Because if you get a triangle that is some multiple of that, the ratios are going to be the same. The trig ratios are always the same. It doesn't matter how big the triangle is. And what is the sine of 30 degrees, which is the y-coordinate? Just get used to doing it. Yep. And that's always the case. And that's a good one to memorize. Memorize that the sine of 30 degrees is 1/2. And you'll eventually, after doing it over and over and over, you'll memorize that the cosine of 30 degrees is root 3 over 2. Always. It's not a decimal number. It's root 3 over 2. Okay? So that particular point right there has those coordinates, root 3 over 2, comma 1/2. Okay? Now, let's talk about the coordinates. This is quadrant, or the quadrants. Quadrant 1, quadrant 2, quadrant 3, and quadrant 4. In other words, they're numbered counterclockwise, not clockwise. Okay. Now, the moment they start teaching you the unit circle, they're going to say to you, at some point you're going to take a test, and you're going to have to give me, here, let me erase some of this so I have a little bit of writing room without erasing what I want you to eventually take a picture of. I'll tell you when it's time to take the picture, not yet. Okay. And then I'm just going to say memorize everything you see in that picture. I'm going to go up here and I'm going to change these to to theta, excuse me. Because the sine of theta is always the y-coordinate in the unit circle. And the cosine of theta, whatever theta is, and this I'm going to make theta, whatever that angle is, the cosine is the x-coordinate. Always. So tell me what the cosine of 0 degrees is. Based on the fact that the cosine is always the x-coordinate and the sine is always the y-coordinate. So what's the cosine of 0 degrees? What's the x-coordinate of that point? That's 1. In other words, it's this point right here. Right? Because if I had the cosine of 30 degrees, I'm still on the x-axis. I haven't rotated it at all. 0 degrees leaves it on the x-axis. So if I know that the cosine of that angle is always the x-coordinate, I can see that the x-coordinate is 1. Now what's the sine of 0 degrees? Correct. Okay. Now, let's move our angle up so we have a 90-degree angle. So now we got an angle, put it in blue again. In other words, our angle is now 90 degrees. What's cosine of 90 degrees? Cosine's always the x-coordinate. No, what's the x-coordinate at that point? You got it, just say it. can see you understand it. It's 0. So the cosine of 90 degrees is this x-coordinate that says 0. What's the sine of 90 degrees? Okay. Keep going around, and we'll go to 180 degree angle. It's cosine of 180 degrees. What's sine of 180 degrees? Okay. Let's go all the way around to 270. In other words, this angle right here. What's cosine of 270? It's the sine of 270. There you go. Okay. Now, from that information, you can answer a bunch of questions. A lot of sine and cosine questions. So the first one I'm going to give you is what's the sine of 45 degrees? Don't rationalize. Just give it to me with the irrational number in the denominator, which most trig teachers say is fine. Trig teachers do not need you to rationalize it. Not in this day and age. They just don't. It's the trend. You may still have one that wants you to rationalize these answers, but it's far easier if you don't rationalize them. You'll learn why later. But so what's sine of 45 degrees? What's cosine of 45 degrees? Say it. No, same thing. 1 over root 2, right? Cosine is adjacent, which is 1, over hypotenuse, which is root 2. Okay. I'm going to go through all of the ones that you have to memorize in the first quadrant. It's the sine of 30. Cosine of 30. And sine of 60. What's cosine of 60? Good. Now, you know what the sine and cosine of your key 3 angles are, 30, 45, and 60. And I've showed you with this drawing of the unit circle what your sine and cosine of your quadrangles. A quadrangle is a multiple of 90. So 0, 90, 180, and 270 are all quadrangles. Okay? So with the information you see on this page, and you don't really need the stuff on the blue left because you can figure those out from the 2 triangles, so I'm going to erase them. Okay? You now know everything they want you to memorize, but you only know it for the first quadrant and all the quadrangles, right? In other words, if I ask you what the sine of 180 or 270, you could give it to me. If I ask you what the sine of 30, 45, or 60, you could give it to me, right? Okay, so now let's talk about the second quadrant, because trig is not just about first quadrant. In other words, those first quadrant angles, sorry, I thought I had it on erase. I thought I had it on draw. It was on erase. There's the 45, there's the 60. Those are the only ones they expect you to memorize. They're not going to ever say, what's the cosine of 29 degrees? The only 3 they want you to memorize in each quadrant are the multiples of 30 and 45. So if I extend that all the way around, well, there's a 120 degree angle, right? There's a 135-degree angle, in other words, 90 plus 45. And there is a 150-degree angle. Now, do you know what I mean by that? In other words, when I say that's 120, I mean from there to there is 120. With me? Okay, so here's the secret. Whenever you're figuring out a trig function of an angle greater than 90, you use this formula right here. If it's in the second quadrant. If it's in the third quadrant, you use this formula. And if it's in the fourth quadrant, you use this formula. Now that's pretty much it. That's just almost everything you need to be able to answer any trig question. So let me test you. What's the sine of 120 degrees? Well, theta is 120. So if I have a way I like to do this, I figure out what its equivalent first quadrant angle is. And what you use to figure those out are these. So plug in 120 for theta. First of all, figure out which quadrant 120 degrees is in. It's 180, that's 90, that's 270. So which quadrant is 120? Okay, plug in 120 for theta, and what do I put in the parentheses? So it's going to be the same numerical value as the sine of 60, which we already know to be root 3 over 2, right? Okay, now, one last thing I need to add. All students take calculus, ASTC, counterclockwise. What the A means is that all 6 trig functions are positive in the first quadrant. In the second quadrant, the S means that only sine is positive. Cosine and tangent are both negative. With me? Third quadrant, tangent's positive. Sine and cosine are both negative. Fourth quadrant, cosine is the only positive one. Sine and tangent, both negative. So, I have almost figured out what the sine of 120 degrees is. I have its absolute value. The only thing I need to do is add a plus or minus sign to that. So what is it? Plus or minus? Good. Let's do another one. Cosine of 120 degrees. So in parentheses, tell me the equivalent first quadrant angle. Use 60, right? Is that what you said? Yeah, it's 180 minus 120. Okay, so now figure out what the cosine of 60 is. Now just figure out the number first. There's a certain method that I use that I really would like to see you stick to. You always do it this way. In other words, first figure out what the numerical part of the answer is. So what's the cosine of 60? 1/2. 1 over 2. Now figure out the plus or minus sign. There you go. And I'm not sure why I like that order. It's just that it's very easy to figure out the numerical part of it, and then using ASTC, all students take calculus, you can figure out its plus or minus sign. And it's as simple as that, okay? You basically now have everything you need to figure out complicated angles. I'll give you another one. Let's do sine of 210. Figure out the equivalent first quadrant using this, because we're now in the third quadrant, right? In other words, you have to figure out, first of all, which quadrant you're in. 210 is in the third quadrant. Okay? Now figure out its equivalent first quadrant angle. Substitute the 210 for the theta. (210 minus 180). 30, okay. Now figure out the sine of 30. Nope. Sine of 30 is always 1/2. That's one you're going to memorize, and might as well memorize it sooner than later. You can use this triangle every time, but you get the sine of 30 a lot. So the sooner you memorize it, it's 1/2, better off you're going to be. Okay? So that's 1/2. Now put the plus or minus sign on it. Good. Okay? That is the pattern and the method you can do, and you can now give me the sine or cosine. You now have the entire unit circle figured out. In other words, here's the test they're going to give you. At some point, you're going to draw a circle like this. You're going to chop it up into 16 parts. And they're going to say, what's that point, what's that point, and what's that point? Okay? Well, that bottom one is a 30-degree angle, right? And what do I know? I know that the x is the cosine of 30 degrees. What's that? And the y is the sine of 30 degrees. It's 1/2. That's the coordinates of that point. This is the 45-degree angle point. Tell me what the coordinates of that are. That's the x coordinate. And the y coordinate. Good. And this third point is the 60-degree angle. So give me the coordinates of that. Hmm, 60. Cosine of 60 is what? Yeah, notice the cosine of 60 is the same as the sine of 30. And they are always interchangeable like that. The sine of 20 is the same as the cosine of 70. The sine of 10 is the same as the cosine of 80. Okay, so this point here is basically the interchanging the bottom one. This is 1/2 √3/2. You know what this point is? What's that point? It's 1, 0. In other words, the x coordinate is 1, y coordinate is 0. And this point up here, notice that you have just memorized, or not memorized, can figure out, because that really is the secret. You don't have to memorize it. Humans are not very good at memorizing 16 points. Notice that I have 4 points in each quadrant. I got to do the same thing over here, and there, and there. And then the same thing there, there. I left out a middle one there, and the same thing here, here, and there. There are 16 points on the unit circle. They want to know the coordinates of all 16 points. That is your unit circle test. Okay? You do not have to memorize them. What's useful if you memorize the first quadrant, but you can actually figure out the first quadrant, everything from these two red triangles, right? And the knowledge that the x-coordinate is the cosine of the angle and the y-coordinate is the sine of the angle. So between those two things, you actually can figure out the first quadrant. And between these other things, that and this, you can basically change any angle that's inside the unit circle to a first quadrant angle, right? So you can figure out the numbers, and then you figure out the plus or minus sign based on ASTC. So everything you're looking at there, here, let me erase this because you don't really need to memorize that. You don't need to memorize any of this. I'm going to erase this unit circle over here because I don't want you to memorize it. I want you to just be able to figure it out. Okay? So, everything you see here, I want you to memorize. Starting at the top right, so you know that the sine of the angle is the y-coordinate, the cosine of the angle is the x-coordinate, and there's nothing here that you don't have to memorize except for maybe the stuff inside this unit circle. Let me erase that. That's just to help you understand what we're talking about when we talk about these angles. Now, you could take a picture of that, memorize everything on it. But let me add two other graphs. One is the sine curve, the other is the cosine curve. And it's extremely useful to memorize these also. And not just memorize them, but know how to dimension them. That's 360 degrees. That's 360 degrees. They both go up to a maximum of 1 and down to a minimum of -1. Now, and this is 180. The peak comes at 90. The bottom comes at 270. Whereas in this one over here, that's 90. That's 180. And that's 270. Notice those three quadrangles are key points on the sine curve. That's where your maximums, minimums, and zeros occur, is at those quadrangles. Now, if you take your camera out again and take a picture of this. Hold on, before you do it, let me label that y equals sine of x. And let me label this y equal cosine of x. Now, take a picture of that. Okay. Now notice that if you memorize these two curves, then you can answer all these quadrangles. If looking at just the sine x curve, what's the sine of 0 equal to? Don't look at my unit circle stuff. That's another way to do it. I want you to be able to do it both ways, because actually the way on the left will work better for you, because the sooner you get these two curves memorized, everything about them, the better off you're going to be. So what's the sine of 0? Oh, that's your y, that's your y, that's your x. Plug in 0 for x. Where does it fall on the y scale? What's the y value when x is equal to 0? Yeah, where my big blue dot is x is equal to 0. Okay, so the sine of 0 is 0, right? Which agrees with this over here on the right. We know the sine of 0 is 0 because the y-coordinate is 0. With me? Now, take your eyes and put them back on the two blue graphs. Tell me what the sine of 90 is. What's the sine of 180? Oh, look where 180 is. Right there. 0. In other words, you have to find the spot on the x-axis, and then you have to look at what that y value is. That's the way you do this. Okay? So what's the sine of 270? Yeah. So this graph, the blue graph, completely agrees with all of my quadrangle points on the unit circle. What's cosine of 0? Looking at the blue graph. Nope. Find 0 on the x-axis and then find what the y value is. Okay, there's 0 on the x-axis, correct? What's the y value? I'm not merely meaning to, I didn't mean to draw the dot there. That's 0 on the x-axis. What's the y value? Okay, what's cosine of 90? What's cosine of 180? Cosine of 270? Nope. Look at it where it's at on that graph. Okay, and cosine of 360. Good. So if you memorize this graph well, meaning you can recreate it. In other words, if I erased both of those graphs and I said, draw me the graph of y equals sine x, you could do it. Then you don't need this other method. Where the other method that I'm referring to is where I know what that is, I know what that is, I know what that is, and I know what that is. Therefore, I can figure out what the sine and cosine of your quadrangles are. But since you have to memorize these curves on the left eventually anyway to get through this trig course, sooner the better, then you don't need that technique. You can use this technique over here on the left, which is actually quite a bit easier. Just look at the graph. Okay? Now, you could pass an easy trig course with just what's on this page. Seriously. Yep. What I'm going to do is just drill you the rest of today. I'm going to give you various angles and let you tell me what their trig values are. Okay? So I need a little writing room here, so I'm going to erase my two graphs, which are helpful but not actually necessary for the following drill. I'm going to basically just ask you about sines and cosines of certain things. So tell me what the sine of 300 is. Use this little technique where when you're doing it, I want you to write sine of 300 and then in parentheses, I want you to write what its equivalent first quadrant angle is. Correct? Okay, so 60 goes in there. Now what's the numerical value of sine of 60? Now put the plus or minus sign on it as your last step. Correct. Okay, good. What is the cosine of an angle outside of the unit circle, bigger than the unit circle. What goes in the box, in the parenthesis? Positive 30. In other words, if your angle is greater than 360, then your first step is to multiply or to subtract all multiples of 360 from it. Well, I can subtract one multiple, leaving me with just 30. Okay, what's cosine of 30? What's its plus or minus sign? Which quadrant is it in? Yes, it's in the first quadrant. It's in the first quadrant. Because what you basically do is you go around the unit circle twice, or not. You go around it once full time for 360, and then do another 30. You're still in the first quadrant. So now you know how to handle angles greater than 360. So now you can do the cosine of any angle as long as it's a multiple of 30 or 45 degrees. You can come up with a numerical answer. Okay. Now there's a key trig identity that you need to know. Tangent of x, meaning an angle, we always take trig functions of angles, happens to be equal to the sine of x over the cosine of x. So tell me what the tangent of 30 degrees is two different ways. I want you to tell me what it is from the red triangle in the top left first. Okay. So we know that's the answer. Now let's do it this way. So the tangent of 30 would be equal to the sine of 30 divided by the cosine of 30. What's the sine of 30? What's cosine of 30? Simplify that. How do you solve that? Dividing a fraction by a fraction? By the reciprocal. You got to do two things. You got to flip the bottom, flip and multiply instead of dividing. You flip and multiply. Well, that gives you 1 over root 3, which we know to be the correct answer. Okay. But whenever you're dealing with tangents, no, you can always use this technique. In other words, this isn't really necessary at this point. You don't need that. Because you can always answer the problems from, well, you kind of need it for your quadrangles. Okay? You don't need it for any angle that is a multiple of 30, 45, or 60, unless it's a quadrangle. And then this is useful. Tangent of x being sine of x over cosine of x. But otherwise, you can just use these two red triangles, right? In other words, what's the tangent of 45 degrees from the red triangles? Yep, just 1. Okay? Where this is useful, I was going to erase it, and then I realized, no, it's useful for the quadrangles. And I'll explain. So, the quadrangles start with 0. So, there's no 0 in these two red triangles, so you can't use those. But, you know, it's the sine of 0 over the cosine of 0. What's sine of 0? Go over here and 0. In other words, it is the y-coordinate right there. The y-coordinate is 0. Divided by the cosine of 0, which is what? What's 0 divided by 1? Okay, so the tangent of 0 is also 0. Now, let's look at a tougher one. Tangent of 90 degrees. So that's the sine of 90 divided by the cosine of 90. What's the sine of 90? What's cosine of 90? What's 1 divided by 0? Nope. Undefined. You cannot divide by 0. Ever. So whenever you have a number divided by 0, it's basically infinity. But they call it undefined. Okay? So now we have trig functions that don't actually have a ratio. The tangent of 90 degrees is not defined. And there's going to be other trig functions that are like that too. But if I go all the way around and I say what's the tangent of 180, well now it's 0 divided by minus 1, so the tangent of 180 is also 0. But if I say what's the tangent of 270, it's negative 1 divided by 0, that's undefined also. So you have the tangent of 90 and the tangent of 270, which are both undefined. All based on the fact that tangent is sine divided by cosine. Okay? Alright, here let's see if we can solidify this a little bit more. I'm just having you do some. This is what they would give you for homework. You'd have a whole page of give me the trig function of what's the tangent of 225, stuff like that. So let's do that. What's the tangent of 225? First question is what? What quadrant is it in? Okay, second question is what's the equivalent first quadrant angle that goes in the parentheses? Third, what's the tangent of 45 from the red triangle up above? And what's the plus or minus sign in the third quadrant for tangent? Big T right there. Third quadrant. Remember, it's A, S, T, C. Here, let me put the T right there. Let me put the S right there and the A right there. Okay? And then I'll erase them from up here. Just kind of cover it up. Okay. So, it's plus. Tangent's positive in the third quadrant. Okay. There's the cosine of 135. Okay. Remember, all of these are going to come out to be 30, 45, or 60. They're not going to, they would never ask you what the cosine of 125 is, because that would require you to know what the cosine of 55 was, and nobody knows that. You pull out your calculator for those. But these angles that are multiples of 30 and 45 degrees, they want you to memorize those. What's the cosine of 45? And what's its plus or minus sign? I could drill you for another 10 minutes on this, but I think you got it, don't you? You got the technique down? So you can do any angle. Okay? Let's talk about negative angles. Negative angles where you start from the x-axis and you rotate your ray clockwise, not counterclockwise. Okay? So if I gave you that angle right there, that's 30 degrees. That's actually a negative 30 degree angle. Or I could say it's this angle, positive 330, and they're the same. Negative 30 is the same as positive 330. So you could do things a few ways. Let's talk about the sine of 30 degrees. Okay. Now let's talk about the sine of negative 30 degrees. So first of all, what's the equivalent positive angle that equals negative 30? I don't want to put it in parentheses. I use brackets for this. Just look at that unit circle. I drew a picture. 30 is the same as, no, negative 30. I'm sorry, I worded that incorrectly. Negative 30 is the same as positive 330. In other words, it has to be 360 degrees difference from it. Okay. Now, what's that in parentheses? In other words, now everything's being based on the sine of 330 degrees. Okay. Now what's the sine of 30? What's its plus or minus sign? Because it's in the fourth quadrant. So that's one way to do it. Take your negative angle, you turn it into a positive angle, and then just work from the positive angle. Okay? In other words, had I asked outright what the sine of 330 is, you'd have just had this step and that answer, right? Well, I threw in a little kink. I asked you the sine of a negative angle, so you had to turn it into a positive angle first, and then proceed. Okay? So now you can do all negative angles. But there actually is a little bit of an easier way to do sine of a negative angle. And this is a property of trig. Sine of a negative angle is the same as minus the positive sine of the angle, like that. So now if I said the sine of negative 30, it's the same as negative the sine of 30, and you immediately get to negative 1/2 without going through that big angle and having to convert it back to 30. So the second method's a little bit easier, and the one you should use. Problem is that this is only true for sine and tangent. I'm going to give you three identities here. The tangent of negative angle is also the negative tangent of that. So that's true for sine and tangent. For cosine, it's different. For cosine, this is true. It's not negative. In other words, the cosine of negative 60 is the same as the cosine of 60. Cosine of negative 60 is exactly the same as the cosine of 60, which is 1/2. So when you have a negative cosine angle, you want to use this third identity. If you're dealing with sines or tangents, you can use these first two. The first two are odd functions. The third one is an even function. Remember your odd and even functions from algebra? Well, the definition of an even function is if f of minus x is equal to minus f of x, which is what sine and tangent follow. Excuse me, those are odd. That's the definition of an odd function. And an even function is f of minus x equals f of x, which applies to cosine. So cosine is even, and sine and tangent are both odd. And it makes it a little bit easier dealing with negative angles if you know those three identities right there. Some of this stuff you don't have to memorize it all in one day, but guarantee you, when I said take your camera out and take a picture of it, you do want to memorize every single thing in that picture. By memorizing it, I mean, can you create it? In other words, if a student came up to you and said, can you give me the lecture on the unit circle? Could you draw everything that's in your picture from memory? That's how well you want to memorize. If you can't do that, keep working on memorizing. The moment you can do that, and that's the way to test yourself. If you think you've memorized that page, see if you can draw the page. Replicate it. Everything from SOHCAHTOA to those two red triangles, to everything in my unit circle, to those three identities on the left. Not this so much, because all I was showing you here was one way to handle the negative angles, but it's not really the best way, it's not the quickest way. So, no reason to really memorize that. However, those other three, you do want to memorize those at some point. It makes it a lot easier to figure out negative angles. All right, it's 7 o'clock. That's usually how long this little lecture takes, is about exactly an hour. But it's extremely valuable. This will take you a long way in trig, Brandon. It really will. Tremendously long way. I don't know if you could pass a trig course just on this, but you could impress a teacher if you knew this starting out the gate. Okay, there's a lot more trig than just this, don't get me wrong, but this is huge. You can get this down and be able to solve without a calculator sines, cosines, and tangents of any angle that is a multiple of 30, 45, or 60, or 90. Well, that's a multiple of 30. So if you can do that exercise with any angle, you're 90% understanding trig. Okay? And I will let you go with that. This should be quite helpful. You'll probably get to the unit circle. You may spend time talking about converting between degrees and radians. Have you done that yet? Okay, that'll come next. And then they'll do the unit circle. Okay? All right. Brandon, have a good weekend. I'll talk to you next time.